Okay, I guess I'm not sure if these are 50 or 30 millimeters, but I would have to use 50 and 30 millimeters, either 50 or 30 millimeter deductive fans for airplanes, and I'm going to cut it down and shorten it so that the blade will fit here. And the motor bracket, I'm going to be using a pancake motor, which is similar to this one, and it should fit into the motor bracket that I'm going to mount here, and the rotary blade should fit within the housing area. And that's what I'm going to use to fly this. I thought of using the landing gear to move it forward and to allow it to thrust from in a vertical position while the rotary is fit within that belt. So the belt is going to be here. This is just going to hold the motors within there in a rotary. I'm going to aim it upward so I can thrust it downward here, and aim it either the forward so I can thrust it down here. Now, I would have to put a cage over here, like a mesh, so that the blade doesn't hit me in the face. So I'm going to be using like a steel mesh over it, and that will protect me from when I'm wearing the garment just for protection. When it slams into, or try to wear it to slam into my face, and I would need the protection on there. So hopefully that the motors and the rotary should fit, and the propellers, I'm probably going to make a little hole so that it slide a little bit forward and make a circular bevel part so the motor can fit snug right in there, and the blade right here. So therefore it only depends on the size of the motor, really. And so I put over the plastic that I cut out the garbage can, and I put some film on it here, some kind of film to cover up the plastic parts. The following I did for the Mark 42 unit was the chest, mechanical chest with the actuated abdominals, and the abdominals actuate like that, fix up like that. I applied the motors, pancake motors like these, localized on the side to remove the armatures. I still haven't changed the motor blade, but I did add two cylindricals where I could bladder the thrust through both directions, and to try to add more thrust to the system. This is light. The back of it, I applied a mesh behind it. I will still have to glue these parts in. I'm not going to hot glue it, but I'm going to use some stronger glue than that. The mesh allows the vacuum. This is very like iron mesh, but it's soft, but it's belted to it so it doesn't cave in on the rotary. The rotary is facing this way, and it does vacuum to this vacuum. I want a stronger vacuum so that the suction for suctioning against the body. Now, I'm folding up the segment for it to actuate downwardly towards the abdominal area. Will be kind of a little bit simple, not complicated, powered by a motor, and to actuate the abdominal sets. There's going to be another set that I'm going to put under there, which is going to be localized right under there. It's going to drop down along with it. Now, the rotary motors I have to place in here for the system. I've opened up a whole area so I can mount the motors in. But these are not the motors I'm going to use for it. I'm going to use a better high torque. These are 5010s. This give off, it uses a blade that's 10 inches. And it's too big for this. So, and it gives off 10 pounds of thrust. So I'm not going to be using that motor. This is the frontal for the unit. This is the back brace. This is the layer side for the lay for it to vacuum on. I have to put a mesh over a speaker mesh, which is a hard density for speakers to protect the speakers. So I'm going to put that over here. This is where the part will be vetted. The part of the cockpit, the back vertebrae part that shall be vacuumed on the back. This is how the armor flies to capture the back. I have, like I said, I have these fiber optic wires that have sensors. These sensors are to indicate for distance and measurements and proximity sensors. I have first distance, long distance. I have also sensors in the back. That's one going upward, north, south, east, and west, north, south, east, and west. Sensors. I have the sensors in the front that are for up, for left, upward, and right, downward. It's localized over here. I have to put the fiber optic wire in there. Here's one with the fiber optic wire that heads it there. The shoulder unit that I have, that I'm still doing. This is the shoulder unit for the drone to allow it to connect for the shoulder body armor. And the rotary is, I don't have the rotary in here yet. I'm gonna apply it. It's the housing area as far as the metal. It's about 152 millimeters, so it's more than 120 millimeters. And I'm gonna be using that for thrust and for the I have two shoulders, so I'm doing that. The next part is the legs, to show you how the legs work for the gripping and manacle gripping. These parts are like casting, so I could restructure it over in iron. Maybe using roofing metal for that, which is way more lighter than the plastic. or titanium, which is being more light than the plastic. And to design it the same way, I just needed to locate the areas that I'm going to modulate, either left side of my back, lower back, or upper back. This is the lower part, this is the upper part. So the left side or the right side. So I just need to know where to implement the little units, the modulations, the modifications, so that it will work much more better. Now I have holes in here which I implanted speakers. And I'm going to be using PIR sensors here and a camera here. So that will be the optical viewer to be able to view my body and biometric lens. Here I also have to modify it with sensors. So the same thing goes with all the different uniquenesses of Mark 42, and try to translate these and convert these things into like realistic type iron and flywheel. Now this is a sensor. It's usually to calculate the spinning and rotation of the motor. So I'm going to also be implanting this on the other side, actually this side, the frontal side, over the mesh, and that would calculate the spins and the rotation. However, it still would allow air to propagate through these open clearances. So I'm going to mount it along with the mesh. Now I have put a mesh behind here for, like I said, for the air to protect, but it's going to be much stronger than that mesh.
However, I'm going to enclose this material part apparatus so it should be downward like a cylindrical bomb sampler. However, I have two formulations. One, I could go out here to go in, like a cylinder sampler, CO2, and exit out back to cylinder restriction by the rating. Listen to that. But the ear will rotate around a cylindrical chamber and distract and bleed outwardly. So I can have it that way to transfer air from place to place.
The tubing for the leg, the thigh. This is the thigh, that's the calf area. So I would have to carbon fiber it. And make the other two so that these four go alongside with one another, and having the embedded the rotary in that shaft. So to speed up the casting process is to add those things and then cast over that to connect to this part of the calf area. Both servos are supposed to be attached, coupled. The servo arm is supposed to be coupled to, attached to the fan drum. So right here, the drum fan, right here, the inductive is supposed to be attached to the drum fan shaft. Over here on the same side, and this is supposed to be attached to here. I'm going to use a latch and scissoring to fold the scissoring so that this part right here, this latch will be zigzag, and I will move this on top of there so I can shift it over and it'll be alongside and then fold around the body. So to have 4 inductor fans, so it can sit like a drum. I'm going to use fly for the hippo. So this is the hip ROM biaxial legs correctly. I'm also going to put the feet there, but I have to do these things in these plastics before I step up to gauge of metal, iron, about 3 millimeters, a little bit over 3 millimeters. So right now I'm going to set this up first before any kind of changes happen. So goodbye. I'm Jermaine Morton. I'll be back. Goodbye.